Hello friends, in this video we discuss Wolff Kishner reduction reaction and its mechanism. It's one of the very important reaction for the conversion of aldehydes and ketones to their corresponding hydrocarbons. Aldehydes and ketones, C double bond O. We know that we always use C double bond O to represent aldehydes and ketones since carbonyl group is the reactive site of aldehydes and ketones. When it reacts with hydrazine NH2 that is the first reagent we need for the reaction, and this one is hydrazine, and the second reagent is potassium hydroxide KOH. Then you need ethylene glycol as a solvent. Ethylene glycol is just acting as a solvent there. Then C double bond group gets converted into CH2 group. You can see that one oxygen is replaced with two hydrogen atoms. When you remove that oxygen, two valencies of this carbon are free. So we are two hydrogens. So we will see one or two examples for that. So if you take an aldehyde R C double bond H, when you treat it with all these reagents, then you will get RCH3. Similarly, if you take a ketone RC double bond O R dash RCH2 R dash. Now we'll see the mechanism of this reaction. Consider an aldehyde or ketone C double bond group. The first reagent that reacts is hydrazine here. Oxygen atom of carbonyl and the hydrogen atom of hydrazine reacts to form water molecule. One water molecule gets eliminated from there. Then the resulting compound is C double bond NH2. This compound is known as hydrazone. So hydrazine is the reagent, and when it reacts with C double bond O, you are getting hydrazone. The second reagent acts here, which is KOH. You know that KOH is an ionic compound. It ionizes to form K plus and OH minus ion, and this OH minus ion attacks this hydrogen. Then this shared pair of electrons will move back to the nitrogen atom. Then you will get carbon with double bond N, single bond NH with a minus charge. Minus charge is due to the movement of that shared pair of electrons to nitrogen. Now, when this lone pair moves here, this double bond shifts back to the carbon atom. Okay. Otherwise, around the middle nitrogen, there will be 4 bonds. So, when this shift takes place, you will get C carbon with a negative charge, single bond N, and then double bond NH. Now, next reagent, that is water molecule which gets released here, right? So that water molecule react here. H2O. H2O, you know that ionizes to form H plus and OH minus ion, and this negative charge acts on this H plus, and this hydrogen gets attached with this carbon. Then single bond nitrogen, double bond NH. Now the next step is again the reaction with KOH. So we have, this is the first step and this is the second step. So in the second step, you can see that KOH attacks over C double bond N thing. So here also the same way, K plus OH minus attacks the hydrogen and the bond shift back to nitrogen. So you will get carbon with nitrogen, double bond N with a negative charge. When this negative charge shift, and then this bond breaks, and then move back to carbon. And when this negative charge on the nitrogen atom shifts, you will get a nitrogen triple bond nitrogen. That means nitrogen gas gets removed from there, and the resulting compound will be carbon with a negative charge and with hydrogen atom. Now again, it reacts with another molecule of water. Okay, water gets ionized to form H plus and OH minus, and this negative charge attacks on H plus, and you will get CH2. So when you consider this reaction first step, this is the third step, and this is the fourth step. And you can see the fifth step, it is similar to the second step, right? So reaction with KOH. After that, what is the next step? What is the sixth step? Sixth step is again the same thing, movement of that lone pair of electrons. And what is the seventh step? Seventh step is similar to the fourth step, reaction with water. So we have total 7 steps in this conversion. So we have started with C double bond O, and then you are getting CH2 group. Okay. So I hope you got this mechanism. Thank you.